this video, we're going to look at the second half of the 2.2 notes, which is using complementary and supplementary angles in proofs. As you work this through, it's important that we know the definition of what it means for angles to be complementary or supplementary. So if two angles form a right angle, then the angles are complementary. And if two angles form a straight angle, then they are supplementary. So these two words carry a bunch of power for us. They tell us that two specific angles are forming a straight angle. So that means that we have a straight angle in a diagram, or it gives us measures of 180. If they're complementary, this is extra helpful because this tells us that two angles we have in a diagram are forming a right angle, which gives us right angles to work with, which in geometry is an amazingly helpful thing to have. So let's actually look at some proofs. So first thing, as a reminder, please mark your diagram as we look through these, and then we're going to figure out our logic steps as we go. So for example 1, given ray EG is perpendicular to ray EO. All right, so I have perpendicular segments. Then they want us, and so thus far, until we make some other conclusions, there's nothing else that we can write yet. Prove angle GEM is complementary to MEO. Well, now's the point where I want you to start thinking about the logic. If I asked you to just explain to me in words without a proof why it would make sense that if those segments are perpendicular, angle GEM has to be complementary to MEO, I want you to think about what you might say. Why does this make sense? So as I think about this, as I think about the logic chain here, I think, well, okay, perpendicular means angle GEO is a right angle. So I could mark that. Well, angle GEM and MEO, what do I know about them? Well, those two angles are a part of my right angle. So that means that those angles have to be complementary. Since they are the two angles that make up my right angle, they have to add up to 90, even though I don't know what the measurement of them are. They have to be complementary. So in order to show that angles are complementary, we need to first show that those angles are inside of a right angle. So now, looking here at this flowchart, I can think about the logic here of why this would work. And I don't think we missed any steps. We have everything that we need. In order to prove complementary, we need to know that the angles form a right angle. We have that here. So let's go ahead and formalize this in a proof. So what we need to do is anything that's beyond a given, we need to make sure it has its own unique step. So let's make our two columns. We have statements and we have reasons. And then I'm going to go ahead. Step 1 is always to restate our given information. So our given, we can't start a problem without a given, is ray EG is perpendicular to ray EO. And our reason for that is it was given. Okay, so next up, whenever you see perpendicular lines, I sure hope your mind goes straight to right angles. If it does, we want to make sure that we state that. So then, that was the next step in our logic chain. We went from perpendicular in our mind to right angles. So let's go ahead and make sure we prove it, that because they're perpendicular, I know it's a right angle. So that means that angle GEO is right. And then here, we want to state our definition of perpendicular. We started with perpendicular. Perpendicular, I'm just going to add in a little more detail here. Perpendicular lines imply that we have a right angle. And this is an abbreviation we can use for this. Perpendicular lines imply that we have a right angle. Okay, so now thinking back to our definition. If two angles form a right angle, then those two angles are complementary. Visually here, angle GEM and MEO make up that right angle, so that means by our definition, those have to be complementary. So therefore, we are at our conclusion. We do not need any other steps. And I figured that out by making sure I've said everything by our definitions. So angle GEM is complementary to angle MEO. And then the reason is going to be our definition of complementary angles. If you're having troubles with this, scroll back up to what that is. So this would be if two angles form a right angle, then, and we can use the angle or you can write out then, either one works at this point, then we have complementary angles. Or actually, let's say the angles are complementary, or you can say comp. So if two angles form a right angle, the angles are complementary to each other. So there we go. We've now proved, given two perpendicular segments, that we have two complementary angles. So let's go ahead and look at the same thing with example 2. So here we have example 2 as our diagram as shown. So they didn't give us any given information besides this. So we have to think about what are the things that we can assume from diagrams that we cannot assume from diagrams. Then it asks us to prove that angle 1 is supplementary to angle 2. Well, from a diagram, I can assume straight lines and straight angles. So hopefully you can look here, and if I asked you, well, why would angle 1 have to be supplementary to angle 2? Some of you might say, well, I know that NOI is a straight angle, or I know it's a 180-degree angle. If two angles make a straight angle, they have to be supplementary. And that's exactly the logic. So here's the thing. From a diagram assumption, we can assume straight lines or angles. We cannot assume measurements. So I can't just say this is 180 degrees. I have to say that it is straight. So I could show from there, working out our steps just to get some organization to this, I could show that angle NOI is a straight angle. And then based on the definition of supplementary angles, angle 1 and 2 form angle NOI. So that means that they have to be supplementary because together they make a straight angle. So this would lead us to angle 1 is supplementary to angle 2, or the abbreviation being SUP, S-U-P-P. So this is all we need here. What we need to go ahead and write is our different flow chart now as we go. Okay. So on the left are statements. On the right, we're going to organize our reasons. And we only have one given. We do need to state this given so we can get started, is that we are given the diagram as shown. What this really means is that the diagram contains any of the information you would need to know. You don't need any additional information to solve this problem. All right, given. So the next step. We said that we knew from the diagram that angle NOI was a straight angle. This is an important distinction here. NOI is also a straight line, a straight segment, but we're talking about angles here. So I want to leave segments out of this. So we need to name it as an angle with 3 points with the vertex in the middle, the vertex being O. So this would give us that I pulled from the diagram that this is a straight angle. Not that it's 180 degrees, that it is a straight angle. So this would be angle NOI is straight. Now, a lot of people are tempted to write given. This was not necessarily given to us. This was something, oops, sorry, I dropped my Apple Pencil. This was something that we took from the diagram. Our proper statement for that being assumed from diagram. Assumed from diagram. You have to write this whole thing out. We cannot just write assumed because we cannot assume things in problems. We have to either have it from a diagram or be told it in given, making this point as clear as I can. So then now, looking visually at this diagram, my two angles make up a straight angle. Since these two angles add up to a straight angle, this means that they have to be supplementary to each other. So this means we can actually go ahead and make our final conclusion. Visually, I see that they form that angle NOI. I've already said that angle NOI is straight. So this means for us here that angle 1 is supplementary to angle 2. And now we want to state our definition of supplementary angles, starting with what we are known. We knew first that we had the straight angle. We're concluding they are supplementary. So this would be if two angles form a straight angle, then the angles are supplementary. And if you want, you can abbreviate that as SUP, S-U-P-P. The angles are supplementary. So there might be a part of you that might feel like there's a step missing between 2 and 3. Don't I need to say that angle UON and UOI add up to NOI? Well, it depends on who's proving it. There's certain geometric rules that would add in an extra step here to actually write out that those two angles add up to the big straight angle. For us, it's not necessary. For a proof to prove a straight angle, or to prove supplementary angles, these are your only needed steps. So as you work through these on your own, I am going to put an outline in Schoology so you can look at that outline if you want to get some practice to filling the steps. But I would first encourage you to try these on your own so that you get practice problem solving, trying it out, and then troubleshooting your issues from there. So as a reminder, homework 2.1 and 2.2 are due Sunday by midnight, or if you are a class in later of the week, it will be due Tuesday by midnight, right before you meet on Wednesday. All right, that is the end of the notes.